Okay, welcome to Csis 237 Data Structures course, Lecture 2. In this part of the course, we're going to talk about flow of control, and it's going to be so similar to Java that I really don't think we need to spend a lot of time on this. I'll try to point out some of the differences, some of the main differences between Java and C++. So I'm assuming that you know Java, that you're comfortable with things like Boolean expressions, what they mean. It's essentially the same in C++. Precedence rules are only different in that there are some additional operators, but C++ works the same way as in Java. If-else works the same. Switch essentially the same. If nesting if-else, that is an if inside an if, those kinds of things. Really no difference. Same thing with while, do while, for loops, and nesting of loops. So not much that's different. Hopefully this will be pretty short. Okay, so if you've used logical expressions, logical operators in Java, use them the same way in C++. In math, we use a symbol equal to check if two things are equal on the left and right hand side. Of course, in Java and in C++, instead of the equal, just a single equal, we use equal for equality. And so if you want to check if two things are equal, like x plus 7 equals to 2y, in math we would say x plus 7 equal to y. In C++ and in Java we would say x plus 7 equal 2 times y. You don't need parentheses around the x plus 7, but it's always good to put them around sub-expressions. Always a good idea. Instead of not equal, with an equal with a line through it. In math notation, in programming, whether you're talking about Java or C or C++ or C#, we use the bang equals or the exclamation equals. And the rest are pretty straightforward. Less than, or equal to. These are the relational operators. Same thing in same as in Java. Okay, so no surprises there. One tiny difference is that instead of spelling it out in C++, the data type, the basic data type for Boolean expressions or Boolean variables is bool rather than Boolean. So other than that, same thing. It's got a value of either true or false, and these are predefined. So they are a tiny bit different in that in Java, true and false are keywords, whereas in C++ they are predefined library constants. Truth tables work the same way. They've worked the same way for hundreds of years. And so if you're not used to truth tables, let's take a simple one that is the AND truth table and divide it down this way into the left and right hand sides. The left side is the inputs, so you have two things that you're going to AND together. If the two things are both true, the output, the result of the whole expression, including the AND, is true. So this is doing expression 1 and expression 2. So that's what the truth table tells you. Is if you draw a line over here, these are the inputs over here on the left side, the two inputs, and there's one output. You can think of it that way. That's the result of the whole expression. If the two sub-expressions are true and false, then the result of the AND is false, and so on. So basically you only get a true output if both inputs are true. If you look at OR, you get false only when both inputs are false, the output is false. So it's sort of the opposite, not exactly the same. The OR is true if any one of the two expressions are true. If any one of them or both of them are true, the result of the OR is true. Same way with the NOT, draw a line over here. This is the input, this is the output. If you have an expression that's true, not it, and you get a false. If you have something that's false, not it, and you get true. Okay, so same as in Java. Shouldn't be any surprises here. When you look at precedence, the one thing that sticks out really is just that we have additional operators. So just like in Java, we have a dot operator for class members. We use class name dot method name or class name dot variable name. There's a similar way to use the scope resolution operator. So you can use within a class, you can use the scope resolution operator to access various elements of that class. Or if you have a namespace, you can use the namespace on the left-hand side, colon, colon, and then some variable or function or something on the right-hand side of the scope resolution operator. We'll get to this later. So there are a few things that we probably, well, we don't have in Java. Once we get to pointers, we will see that we can use the arrow notation with pointers. So of course, Java does not have pointers. It sort of does. It uses them in a very safe way and only uses a dot operator. In C++, you can use the dot operator, but it allows you the flexibility to also use this member selection operator. It works like the dot operator, only on the left-hand side, it's supposed to be a pointer rather than a class variable. Okay, so we will get to this only when we, further down the line, when we get to classes, and then this will be important. The rest of this is pretty much the same as in Java. We do plus plus as higher precedence than minus minus. Not operator is higher than and, the and operator, which is way down the list. Okay. Unary minus like in -5, unary plus like in +5, +7. This operator, we will get to these two operators we'll get to when we get to pointers. So there's a whole bunch of new things, including the new keyword and delete. These are all things that C++ has that Java doesn't, and they have pretty high precedence. So just a quick look at some of the things that are different in C++. The scope resolution operator, member selection, dereferencing, address of operator, new, delete, oops, and delete for an array. Those are all new to C++, and you don't see them in Java. So Java has quite a few fewer things in this operator list. These are all the same. Well, there is no insertion or extraction operator in Java, so these are new. Let's see, quickly going down the list. These are completely the same as in Java. Assignment, add and assign, subtract and assign, these are all the same. Conditional operator, even if you haven't used it, it's the same in C++. We can talk about that later. Throwing an exception, we have in Java. The comma operator we do have in Java, but we very seldom use it. And probably won't use it a whole lot in C++ either. Okay, so let's take a quick look at some examples. If you had an expression like this, let's just ignore the rest of it for now. X plus 1 greater than 2. You do the arithmetic before the logical expression. So this is the logical expression, our relational operator. Greater than, you do the x plus 1 first, and then you check if it is greater than 2. And then you get a result which is either true or false. So the result of this sub-expression can only be true or false. Now you look at the right side of the OR, and it's the same deal here. This can only be true or false, and this is always done as x plus 1 first, then you compare with -3. You do not compare, there's no way to say that this is x plus the whichever one is greater. That doesn't make sense. And also, you can apply the precedence rules that we saw in this, and notice that if you look at less than or greater than, these are actually all at the same level of precedence. That is lower precedence than addition or subtraction. So these are all the same. Addition and subtraction are at the same level of precedence. These are all at the same, and these are lower precedence than plus minus. So that is why there is no ambiguity here. Precedence rules remove any potential ambiguity by saying if you have a sub-expression like this, the plus, the arithmetic is done before the relational operator or the logical operation. Short circuit evaluation works the same way. You want to be careful whenever you might change something inside a Boolean expression. So for example, if you have x is, if you're comparing two things, if you're ANDing two things, you're ANDing this expression, this expression x greater than or equal to 0, ANDed with y greater than 1, and has pretty low low precedence compared to greater than, lower precedence than greater than or equal to or greater than. So this is done last. Also, since you have parentheses, this would be done first. Whatever is in parentheses. Just not able to select. Okay, so once again, parentheses are way up. Parentheses, I don't see them here, but I think parentheses has much higher precedence. It's done first. And this is function call. So these are, technically, these are all of the same precedence levels. These are all of the same precedence levels. And I don't see parentheses, but it's up there. It should be way up in that list of precedence. And so this is always done first, that is the whatever's in parentheses. Okay, so now let's say x is 10. 10 greater than or equal to 0, true or false, that's true. And then you AND it with y. It doesn't matter what it is, if y is greater than 1, these are both true, you get a true for the whole expression. Now let's consider the case where x is less than or equal to 0. Let's say x is minus 5. Minus 5 greater than or equal to 0 is false. Now, short circuit evaluation just tells us that if you have a false ANDed with anything, you don't need to do the second part, and so we can skip it. Okay, so that's short circuit evaluation. Java does that, C++, many languages use this. The basic idea is that if you're ANDing two things and the first one is false, there's no point in doing the next thing. The whole thing is going to be false, so might as well skip it, and that's what most languages do. The problem is, or I don't know if you can call it a problem, just something that you want to watch out for. If you're going to change something in this, in this second expression, then you want to be careful. Because what this says really is that you're going to increment y only if x is greater than 1. So if x is greater than 1, this is true, then you have to evaluate this. Now it sort of doesn't make sense to do this, so now think of there being like a y++, I don't know, greater than 5 or something like that. So that would make more sense if you're trying to AND two things. But technically, actually, at least in C, you can do this kind of expression. This would be legal. Java won't be legal. Okay, so the main point is just that if you have an increment on the right-hand side of a logical operator, or increment or decrement, anything that changes something, you might want to watch out for short circuit evaluation, which might skip that increment or decrement or whatever. Okay, so here's the thing. This works differently in Java versus C++. In C++, any non-zero value is considered true. So this, if y was -1, it would still be, this whole thing would be true, and you would AND it as a true value.